You're watching Telecom TV from SCWS World in London. I'm joined now by Raj Singh, who is General Manager of Wireless Broadband at Cavium. Raj, thanks for joining us on Telecom TV. As a semiconductor company, what's Cavium's interest in small cells and HetNets?
So Cavium is a semiconductor company, and we make a variety of silicon. And as we have moved from security to networking to wireless infrastructure, what we discovered was many of the techniques that we did in one area in wired infrastructure also applied to wireless infrastructure. Air interfaces were different. And as we moved forward, many of the techniques for packet processing, crypto engines that we developed a dozen years ago are applicable to the wireless space. So the last 6 or 7 years, we've gone and established a very predominant position in both macro cells and small cells.
So what role does virtualization and NFV play in this sector?
NFV is a catch-all term for many things, and certainly NFV exists both in wired infrastructure as well as wireless infrastructure. It is true that you could do NFV without doing anything to do with parts of the RAN, but it's also true that you can't really virtualize the CRAN without doing NFV, because you need to be able to have virtual machines running different parts of the thing. Now, as you virtualize things, part of the promised land, if you will, is that you're virtualizing them on general purpose hardware. In our particular case, we make the only viable alternative to an Intel server platform called the ThunderX, and it's built from the ground up as a virtual machine chip. It has a built-in 10 gig port, it has hardware VNICs, things that you need to accelerate NFV. It has OVS offload, so you can do very, very fast things and very fast switching times. And that's part of how you want to do it. Now, why do virtualization at all? Virtualization lets you centralize a number of the control and decision-making functions in the network and general purpose hardware. It lets you devolve the control away from the edge of the network so you can manage the network better, you can manage users better. You could take a view that said, instead of looking at SNR readings on a user's device and then deciding to do a handover, because you now have all that data and the X2 control in the cloud, you could look at it and say, I know this user is having trouble, let me move over to that cell, because I can look at both cells automatically in the cloud across 2 virtual machines.
You mentioned that we need to devolve control from the network edge, but at the same time we're seeing an increased interest in mobile edge computing.
But they're not necessarily, they might look like they're competing things. They're not necessarily competing, because in fact, what you want to do is you want to put a different kind of intelligence at the edge of the network. And you want to take the traditional nuts and bolts of the control into the centralized thing. And both have equal weight. And if you look at what's happening at the edge of the network, the kinds of things people want to do is policy decisions based on deep packet inspection, caching video content. These are all good things. It also turns out we do line rate deep packet inspection on gigabytes of data on our chips. So we have lots of expertise for the last 15 years now on hardware deep packet inspection.
So with an eye on the commercialization of 5G in 2020, are we now seeing a rethinking of how we architect cell networks? Because we've been evolving the basic cell topology for 20 odd years now.
Yes, the topology of the network really hasn't changed, actually almost for 40 years. If you think about it, right? You have a cell, you have some central office, data flows back to the central office, you have admission control, you have policy decisions, it authenticates, it sends it back, and there you go. If you try to do that with 5G and you really want faster latency requirements, 1 millisecond against 5 milliseconds on LTE round trip, the laws of physics says it can't go very far. 1 millisecond isn't a huge amount of time. So today, most EPCs are centralized. They may well be virtualized, and it's a huge trend to virtualize EPCs as well. However, they're flat. There's a gateway, there's a router that says go to this EPC versus that EPC, but they're all in the same hierarchy at the same level. And there's a huge move that says, let's make hierarchies of EPCs. There may be one in a local office, one in a neighborhood, one in a district, one in a city. And so depending on where you are and what your reach is and what data you're trying to get to, you may get a very short round trip to be able to meet your 1 millisecond requirement.
And do you think the use of AI, artificial intelligence, will play a critical role in future networks?
So AI is interesting. So there are probably three answers to that. The first is there are things in the network that we can do on a predictive basis. So if you know that 2,000 people end up in a railway station every morning at 8:15, you may want to do something about slicing the network in a particular way. That's a very predictable event. It happens every morning, Monday through Friday. You can manage that. You can do things that are predictive on a post-event basis. The same cell tries to download the same video 4 times. At the 5th time, you cache it, so the next 20 people who do it, you don't have to do it. That doesn't really require a lot of intelligence other than good programming and good management of the resource. In artificial intelligence, you're asking the computer system to go make decisions that are autonomous from human beings. You know, Alan Turing had the right idea with the Turing test, and maybe this is a wireless Turing test to go do. And yes, eventually you could look at neural networks and artificial intelligence that said, oh, I know what's going on here, let me go make decisions. But I think that we have a long way to go in really good programming and being able to slice portions of the RAN to provide appropriate resources to users, where a user who has trying to download and play a 4K video may have a very different requirement to somebody who's making a VoLTE call. And today, the scheduler treats it as a single event, but there are, and in fact we have a demo today of network slicing which manages exactly that use case.
When you talk to mobile network operators, what are their requirements now? What are the issues that the industry needs to address today?
We've got fairly vertical closed systems that are based on appliances. Operators would very much like to have open systems. The extent of that openness, of course, depends both on the operator and their favorite vendor of choice. We're fairly agnostic to who that should be. Almost all of them are our customers. But NFV and virtualization gives them an opportunity to go down that path.
Raj Singh, thank you very much indeed.
You're welcome.